This video presents an overview of measures of dispersion and shape and identification of outliers. Dispersion refers to how variable or spread out a set of scores is. The range is the simplest measure of dispersion, found by subtracting the lowest score from the highest score. It provides a quick and easy measure of the spread in a set of data, but it ignores all but the highest and lowest scores, and is the least useful measure. The variance is the average squared deviation of each score from the mean. The numerator is found by subtracting the mean from each score, squaring this difference, and then summing the squared mean deviations. The sum is then divided by n-1 to get an average of the squared deviations. The variance is expressed in squared units, which is not intuitive. The standard deviation is the square root of the variance and represents the average deviation of scores from the mean. It is expressed in original measurement units and is the most commonly reported descriptive statistic for dispersion. The best way to get a sense of both central tendency and variability is by comparison. This table shows the means and standard deviations for a study of the effect of drug intervention on mild hypertension. Negative scores indicate a decrease in diastolic blood pressure. We see a difference between groups when we compare the means. However, the variability in scores is quite similar between groups. This is how we might visualize these distributions. We don't know their shapes, but we know that the centers are different and that the dispersions are similar, so they might look something like this. The standard deviations of the two distributions are comparable, denoting similar variability. But the means are not at all similar. The last measure of variability is the interquartile range. Standardized tests often report results in percentiles, which divide a distribution into 100 equal parts. The median is in the middle of a distribution, so it represents the 50th percentile. Quartiles divide a distribution into 4 equal parts. We find the interquartile range by taking the difference between the upper and lower quartiles. It is similar to the range, but eliminates extreme values. Let's look at an example of the interquartile range. I'm going to focus on one soccer phenom, Abby Wambach. If you're not familiar with her, here's a little background. She's from Rochester, New York, and she played for the U.S. national soccer team for 15 years. She was also known for scoring goals with diving headers. She has won many accolades, and if you want to see her in action, I highly recommend 100 Abby Goals on YouTube. The variable of interest, x, is the number of goals Abby scored in friendly matches over the course of 13 years. N is the number of years for which we have data. The range is 29, and the median is 11. The lower quartile is also the median of the lower half of the distribution, and the upper quartile is the median of the upper half. The interquartile range is the difference between these values, or 10. The appropriate measure of variability depends on what type of data you have. If a mean can be calculated, that is, if the data are quantitative, then any of these measures may be used. If the data are ordinal, then both the range and interquartile range may be used. There is no measure of variability for nominal variables because the numbers have no meaning. There are several descriptive measures of shape for a distribution of scores, but the one we will focus on is skewness, the degree to which a distribution varies from symmetry. Skewness is easier to picture than it is to describe numerically. This is a theoretical distribution of scores for some quantitative variable. The x-axis represents values for the variable, and the y-axis represents frequency or percentage. This is a symmetric distribution. If I were to fold it along the line in the middle, the two sides will match up perfectly. This is a special example of a symmetric distribution called the normal distribution. It is very important for statistics, and we will return to it in future topics. For now, note that the values of the mean, median, and mode are all exactly the same, at the midpoint of the distribution. This distribution is said to be negatively skewed. There is an extreme score, or scores, at the lower end of the distribution which gives it its skew. Notice that the mean, median, and mode are all different. The median shifts to the left because the number of observations at the lower end has increased, and the mean is shifted even further because it is affected by the values of these observations. This is a positively skewed distribution, with extreme scores at the upper end. The median shifts to the right because of the number of observations in this direction, and the mean increases because the values of these observations are higher. An easy way to remember whether a distribution is negatively or positively skewed is that it always follows the longer tail. If the longer tail is to the left, it is negatively skewed. To the right, it is positively skewed. We can also tell if a distribution is skewed by looking at its skewness value. Values between plus and minus 1 indicate a fairly symmetric distribution. A value less than minus 1 suggests negative skew, and a value higher than 1 suggests positive skew. A rule of thumb for identifying potential outliers is any score that exceeds 1.5 times the interquartile range below the first quartile or above the third quartile. Looking at Abby Wambach's goals, any score that is more than 15 points below the first quartile or above the third quartile would lead us to suspect that it is an outlier. 15 points below 7 is minus 8, an impossibility, and 15 points above 17 is 32. Because there are no values beyond minus 8 or plus 32, there are no suspected outliers. In practice, of course, we examine data sets for a sample of subjects, not just one individual. There are several options for dealing with an outlier. Always report any outliers, including what you did about them. For this course, you only need to know how to identify outliers, but there are several resources available if you want to learn about managing them. The next series of videos focuses on pictorial representations of data.